Hi grade 12s. In the previous video we dealt with the factor theorem and factorizing cubic expressions. Today we're going to deal with solving cubic equations. That just means your cubic polynomial is as an equal to sign in it. So guidelines for solving cubic equations. Firstly, make sure it's equal to 0. Write it in standard form. And then we're going to factorize. You either use the common factor, and that's obviously the easiest one if it's possible, grouping, sum or difference of cubes, and then the factor theorem, which we've done yesterday. And then you apply the zero product rule, which basically means each factor can be 0. Let's look at a few examples. Solve for x in each of the following. Let's look at a. So let's see, is it in standard form? Yes, it's equal to 0. And so now all we have to do is factorize it. There's no common factor. Neither is there the sum or the difference of two cubes. There's no grouping involved here. So we must apply the factor theorem. So we look for possible factors and we test. Go through that whole procedure and we show the one that is a factor. And test f of minus 1, substitute for ABC in x, replace x with minus 1 cubed, minus 3 times minus 1 squared plus 4, and it does result in 0. Therefore, x plus 1 is a factor. So we have our first linear factor, and of course now we obtain our quadratic factor by inspection, which by now you should be able to do. So remember, we're solving this cubic equation. Now we can factorize that quadratic. It gives us x minus 2 all squared. Solve for x. Therefore, x is equal to minus 1 or x is equal to 2. Note that this equation has two real and rational roots. Let's look at our next example. Now, that example is not in standard form. So we're going to take the 5, we're going to transpose our terms. In other words, we're going to 5 to the left-hand side. It becomes minus 5 equal to 0. That's now in standard form, so we need to factorize this. Again, I'm going to use the factor theorem. There's no common factor, and the others do not apply either. So here, f of minus 1, work it out, it is equal to 0, therefore x plus 1 is a factor. Therefore, this cubic expression is now x plus 1, there's my linear factor, and there's the quadratic factor that you obtain by inspection. And this is equal to 0. And let's solve now. So each factor can be 0. So x is equal to minus 1, and this one cannot factorize. So I'm going to use the formula. When I use the formula, I get 3 plus or minus the square root of 29 over 2. Employ my calculator, I get 4,19, or x is equal to negative 1,19. Notice there are 3 real roots. One is rational and the other 2 are irrational. Let's look at the last example. Here we have 2x cubed minus 16 equal to 0. You can divide by 2 on both sides. Find a factor. Now find my quadratic factor. Therefore, x is equal to 2. So I use the formula because this cannot factorize. I find that I have imaginary roots. Therefore, there's only one root, x is equal to 2. There is an alternative solution where, since we've only got 2 terms and the variables in the one term only, we can isolate it. We divide throughout by 2 and then we get x is the cube root of 8, which is equal to 2. Either way is correct. This equation has one real root.